Number 7 is asking us, it's giving us a couple things. It's telling us TO is congruent to SP, so we can mark that right now. It's also telling us that TO is parallel to SP. Now notice that requires different marks. Parallel doesn't say anything about how long they are, and how long they are doesn't say anything about how parallel they are. Parallel really is talking more about the kinds of angles that they make. So by saying they're parallel, they're basically saying that when other transversals intersect, they create the same kinds of angles. There's some angle relationships. They're also saying that TH is parallel to PA. So we're going to mark those as parallel. Okay, so these two. So that means that there are things that we can include about the parallel lines being cut by a transversal. So this is a parallel line cut by this transversal. These two parallel lines cut by this transversal. So we know that this angle has to be congruent to that one by alternate interior. And then these two are parallel, also being cut by the transversal. But the angle that they make, you had to be careful to distinguish it. This line intersects this line right here. And this line intersects this line right here. And those are the congruent angles there. Okay, so because we know those two are parallel, we know these two are alternate interior. Now they want us to prove that TH is congruent to PA. TH congruent to PA. And the best way to do that is to prove that the triangles are congruent, and then the corresponding parts will be congruent. So do we have enough info to prove that THO is congruent as a triangle to SAP? Absolutely, because we have angle, and we have one pair of sides that have a scale factor of 1. So in the proof, I'm going to write that on a separate sheet because I'm running out of room. In the proof, we're going to say, okay, we know that TO is congruent to SP. That's given. We know that line TO is parallel to line SP. That's given. And because we know that, we also then know that angle angle TOS is congruent to angle PSO because those are alternate interior angles. And then they gave us one more thing, that TH is parallel to PA. That was given. And because we know that, we also know that THO, angle THO, is congruent to angle PAS because they're also alternate interior angles. So this is enough to prove the two triangles are congruent. Triangle THO is congruent to triangle, and I want to make sure I get the corresponding angles right. O and S are what match up. So I need to make sure that S comes last, and that H and A match up, so A has to come there. So it's T and P that match up. So THO and PAS. So this is, when you're writing a statement of congruence, you have to make sure corresponding parts are matching up. So this is by angle, right? And scale factor of 1. And now, because we know that these two triangles are congruent, we know that their parts are congruent, so TH is congruent to PA because corresponding parts of congruent triangles are congruent. So that's another way to write that in short. Now, that was A. To prove that triangle STH is congruent to triangle OPA, we may want to rely on some of this information, right? At this point, we now know that TH and PA are congruent, so we can actually mark those with 2 tick marks. So they've got parallel marked, and they've also got congruent marked. And because we know that angle H is congruent to angle A, the other thing that we know is then this right here, angle SHT, has to be congruent with angle OAP because this is supplementary, right? So SHT makes a linear pair with this one, which means that's supplementary, which means that you just subtract from 180 and you'll get that one. Same thing here. These are a linear pair, subtract from 180. So these two have to be the same because they're both 180 minus the same angle. So we can mark those. So we've got this angle, right? And this angle are congruent. We've got a side and a side that are congruent, right? So we've got angle, side. Now the question is, can we get side, angle, side? Can we get another angle in here somewhere? Do we know for sure like what that angle is? Or can we get side, side, side? That's what we need to kind of look for here, is what we're going to find to finish this proof. So I'm going to leave that again as an extra credit problem, because that's an extension that we didn't focus on very much dealing with quadrilaterals. But there is a way you need to either figure out, can you prove by what you know these two segments are congruent? Or can you prove that this angle is congruent? If you just found one more angle or the side angle side, you'd be able to prove this. So that's extra credit to finish B, to add to this proof and finish B.